So first I will start balancing chemical equations. Okay. So I think we discussed in the class Rauch's theorem. So here just I will repeat uh, the concepts of Rauch's theorem. So consider a system of equations Ax is equal to B, where A is a coefficient matrix and X is what? The unknown matrix, and capital B is what? Constant matrix. Suppose the rank of A comma B is equal to rank of A is equal to number of unknowns, then the system Ax equal to B has unique solution. Suppose second case is what? The augmented matrix and the rank of A equal is less than the number of unknowns, means the system has infinitely many solutions. The third one is the rank of A comma B not equal to rank of A, then no solution. So system is inconsistent. So you should know this basic idea. Ritika, okay. So next, so please write the problem. The first problem, balance the chemical equation C3H8 plus O2 gives CO2 plus H2. Maybe you studied these equations in the +1 or +2 level, balancing a chemical equation. So here we are going to use the idea of matrices. Okay. So now I'll start the solution. So you should multiply C3H8 by X1. So X1 times C3H8 plus X2 times O2 gives X3 times CO2 plus X4 times H2O. So means finding the integers X1, X2, X3, X4 such that the number of atoms of carbon, hydrogen, okay, carbon, hydrogen and oxygen are the same on both sides of this reaction. So in which propane C3H8 and O2 give the carbon dioxide and water. So to find the smallest positive integers X1, X2, X3, X4, X1, X2, X3, X4. First, for carbon, we have what? C3. So 3 into X1 is equal to, so right hand side is what? Here we have 1. So 1 into X3. Next, for hydrogen, 8 into X1 is equal to hydrogen, we have what? 2 into what? X4. So 8x1 equal to 2x4 implies what? 4x1 equal to x4. Or next, O 2x2 is equal to 2x3 plus 1x4. So you have now 3 equations. So first equation is what? 3x1 equal to x3. Second equation is 4x1 is equal to x4. Third equation is 2x3 equal plus 2x2, which is equal to 2x3 plus x4. Now from this first equation you can write what? 3x1 minus x3 equal to 0. And then 4x1 minus x4 equal to 0. And then third equation, 2x2 minus 2x3 minus x4 equal to 0. So from this you should form the matrix. The matrix first row is what?
Sir,
Yes?
something, sir.
Yes. Please
I
tell.
cannot see it, sir.
You cannot see the. uh, Okay. So what? I think I shared the screen. Is the screen is visible to you or not?
Yes, sir, but you are not writing in it. Uh,
I'm not writing here. I, I'm writing here. What about the remaining students?
Visible, sir.
Yeah, visible. Yeah, that's why I don't know why for Ritika. Please check your side, check your end. Okay, thank you. Now three. Okay, so now from this you should form the matrices. The first row is what? 3, 0, -1, and what? 3, 0, -1, and then 0. So here I'm writing directly the augmented matrix. The augmented matrix is what? 3, x2 is 0, x3 is what? -1, and x4 is 0. So, okay, this is the matrix A up to this. Okay, and then augmented matrix. Right hand side is what? You have what? 0, 0, 0. So that's the reason here you have 0, 0, 0. Next, second row, 4. Coefficient of x1 is what? 4. Coefficient of x2 and x3 are what? 0, 0, and then -1. So 0, 0, -1. Right hand side is 0. Next, coefficient of x1. Next is what? 0, 0, 2, and then -2, and then -1, 0. So this is augmented matrix. Now here afterwards you need to try to convert into echelon form. So this is equivalent to, what is the transformation you are going to use here? I want to make it, this is already 0, no problem. I want to make it, this is 0. So in place of R2, I need to do what? 3 times R2, because I want here, I need to use this. So 3 times R2 minus 4 times R1. Okay, so first row as it is 3, 0, -1, 0, 0. Second row 12 minus 12, 0. And then here you have 0 minus 4, 0. So 0 into 3, 0, and -4 minus 1 is +4. And then 3 into -1, -3, here have 0. So -3, here it is 0. And then 0, 2, -2, -1, 0. Okay. So now, actually, I need here 0. Okay. So that's why I'm going to interchange the row 2 and row 3. If I interchange these two row, you'll get first row is as it is same 0, 3, 0, -1, 0, 0. Second row is 0, 0, 4, -3, 0, and sorry, I'm interchanging row 2 and row 3. So 0, 2, -2, -1, 0, 0, 0, 4, -3, 0. Okay. So now you can see here, this is the matrix A. Your matrix A is what? This is your matrix A. Okay, this is what? 3 by 4 matrix. So the rank is what? Maximum 3. Rank is maximum 3. Okay, here, what is the rank of the matrix A? R of A is what? What is R of A? Nishant, what is R of A? Yashwant,
Sir, rank is 3.
rank is 3. Rank of A is 3. And what about rank of A comma B? So that is also what?
3.
3. Yes. Okay. Correct. Okay. So, but the number of unknown is what? We have. The number of unknown is x1, x2, x3, x4. So, the number of unknown is 4. Number of unknown
4, sir.
is 4. So, rank of A is equal to rank of A comma B. Rank of A comma B equal to rank of A, okay, which is strictly less than the number of unknowns. Okay. So, and hence the system is what? Possesses system have infinitely many solutions. Therefore, the system have infinite number of solutions. Infinite number of solutions. Okay. So now please tell the first equation here. What is the first equation? 3x1 minus x3 equal to what? 0. From this matrix, 3x1 minus x3 equal to 0. Second equation, 2x2 minus 2x3 minus x4 is equal to 0. Two x1 minus x3 minus x4 is equal to 0. Third equation, 4x3 minus 3x4 equal to 0. Okay. So now, from the first equation, 3x1 equal to x3. So I will take x3 equal to some t. So this implies x3 equal to t and x1 equal to t by 3. So now from last equation, from third equation, 4x3 equal to 3x4. So this implies x4 equal to x4.
Sir, in second equation, it should be 2x2 minus 2x3.
Here x2. Yes, thank you. Okay. Yes, 2x2 minus 2x3. Okay. So now from x4 is equal to 4 by 3 into x3. What is x3? x3 is t. Okay. So now I have what? I need only x2. So from the second equation, 2x2 is equal to 2x3 plus x4. Now substitute the values of x3 here. 2 into x3 is what? T plus x4 is 4 by 3 into t. So this is 2x2. So 2x2 is equal to this is 8 plus 3, 6 plus 4. 10t by 3, or x2 is equal to 5t by 3. Okay, so we have x1 and x2 is here, x3 is here, and x4 is here. Okay, so now write what is x1, x2, x3, x4. So you can check it. X1 equal to t by 3, x2 is equal to 5t by 3, x3 is equal to t, and x4 is equal to 4t by 3. Okay. So now for t, you can give some particular values. You can take t equal to what? You can take t equal to 3. So this implies x1 equal to what? 1, x2 5, x3 3, and x4 4. Okay. So now I have the equation. What is the equation originally you have? The chemical equation. Yes, x1 into C3H8. Okay, well, so this equation you have. Substitute the values there. So first one. So C3 into what? H8. For x2 you have what? 5 O2 gives, I think x3 is 3 here, 3 CO2 plus 4 H2. I think you'll do maximum. I think this is a simple problem. So without matrices, you can easily do and find the answer. But this is a method. Okay, so you should learn here and apply and then you can apply the concept of matrices. Okay, so next topic is traffic flow. So this is the next topic. Okay, I'll stop here and then I'll go to the next topic, traffic flow. So this is the problem. So please write the problem. Find the traffic flow. In a network of one-way street, in the directions indicated by the arrows shown in the figure below. This is the figure. Is the solution unique? That is the first question. Is the solution unique? Second question, and if x4 equal to 200, determine the traffic flow. Determine the traffic flow. So first draw the write the question and draw the diagram.
Excuse me, sir.
Yes, please tell.
Sir, last class we ended with singular value decomposition.
Yes,
We
yes,
didn't complete.
yes. You are right. You are right. So I will take singular value decomposition. I think I gave only title. Is it correct?
Yes, sir. Only the title.
Only the title. I don't give any introduction. Okay. So I feel that for online, class, I feel this is the opt section to discuss with you. And one more thing, I will take singular value decomposition end of this class, because today we have 2 hours we are going to discuss.
Yes, sir.
So first balancing chemical equation, next traffic flow, and then third one is population growth model, and then last one is singular value decomposition. I want to finish 4 topics today, because all of them are included in the second CA syllabus. Maybe tomorrow we have class, but tomorrow class I will take remaining 2 topics. The remaining 2 topics are principal access theorem and then electric circuit. And Monday is the last class for us. Maybe Monday we will discuss some of the applications problems what we discussed today, and tomorrow we will discuss on Monday.
Yes, sir.
Okay. So please write, I think you finished, okay. So now, so using this diagram, you should write this equation. So at this junction, okay, A. So the idea is here, you should write 400 is towards what? A, and 600 is also what? Towards A. Okay, that's why 600 plus 400 equal to, okay, so x1 and x4 are what? Leaving. So that is equal to x1 plus x4. Similarly, if you take B, what is going out? 800, 800. You can see here. What is coming into B? X1 and X2. So X1 plus X2 is equal to 800 plus 800. So there are 4 nodes, A, B, C, D. Next node C. So what is leaving from C? X2 and X3. So X2 plus X3 is equal to 1000 plus 1200. Next, at nodes D, what is coming inside? X3 and X4 are coming inside, and leaving is what? 1000 plus 600. So first you should write these equations. Now from this, okay, from this I should write x1 plus x4 is equal to 1000. From this we have x1 plus x2 is 1600. From third equation, x2 plus x3 is equal to 2200. From the last equation, x3 plus x4 is equal to 1600. Okay. Now you should write this equation in the form of matrices. The augmented matrix A comma B is equal to, what is the first row? 1, 0, 0, 1. One, 0, 0, 1. Right hand side is what? 1000. Okay, and then 1, 1. X3 and X4 are 0. And right hand side is what? 1600. Third row, 0, 1, 1, 0. Okay, is equal to 2200. And last row, Okay, 11, sorry, 0011, 1600. So this is a matrix, augmented matrix. Now try to convert into row echelon form. So first make it, this position is 0. So 1, 0, 0, 1, 1000. So in place of R2 minus R1, so 0, 1 minus 1, 0, 1, 0 minus 0 is 0, and then 0 minus 1 minus 1. So this is what? 600. So I think second and third row as it is. Okay. So 0, 1, 1, 0, 2200, 0, 0, 1, 1, 1600. Okay. So next I want to convert this element is 0. So this is equivalent to 1 first row 1 0 0 1 1000. Second row as it is 0 1 0 minus 1 600. Third row, in place of third row, what we need to do? R3 in place of R3 minus what? R2. So we'll get, you have what? 0 0 1 plus 1, 2200 minus 600 is 1600. So last row as it is 0 0 1 1 1600. Okay. So now next I want to make it this element 0. So in place of R4, R4 minus R3. So this is equivalent to first 3 rows as it is 1 0 0 1 1000. Second row 0 1 0 minus 1 and then 600. Third row 0 0 1 1 1600. Last row 0 0, sorry, yes, the transformation is what? In place of R4 minus R3. Okay, so you will get 0 0 0 0. So last row completely 0. So from this, actually your A is what? Your A is a 4 by 4 matrix. Okay, so the rank is what? Maximum 4, but the last row is 0. So the rank of A is what? 4. So therefore, rank of A equal to 3. And rank of A comma B is also what? Because the rank of A comma, the order of A comma B is 4 by 5. So maximum rank is 4. Okay. The maximum rank is 4. But the last row is what? 0. So here also you'll get what? Rank of A comma B is 3. But the number of unknown is what? You can see here the number of unknown is x1, x2, x3, x4. Okay, the 4 unknowns. The number of unknowns. So rank of A, this implies we have rank of A comma B, which is equal to rank of A, which is strictly, if you want to write, you can 3. This is 3, which is strictly less than the number of unknowns. That is equal to 4. So therefore, the system have infinitely many solutions. The system have infinitely many solution. Okay. So what is the first equation? X1 plus x4 equal to what? 1000. Second equation is x2 minus x4 equal to 600. And third equation is x3 plus x4 equal to 1600. Karthik Raja, why you are late? So late. Okay. So now we have 3 equations. Okay. So now we need to fix any one of the variable. So I'll fix, you can take x1 equal to t, or x2 equal to t, or x3 equal to t, or x4 equal to t. Okay. So I will take x4 is equal to t. So this implies, what is x4? x4 is 1600 minus x3. Yeah. x4 equal to 1600 minus x3. Sorry, I don't need x4. I need x3. What is x3? x3 equal to 1600 minus x4. But x4 is t. So x3 equal to okay. Now what is x2? x2 is equal to 600 plus x4. So, but x4 is what? T. And x1. What is x1? You can see x1 equal to what? 1000 minus x4. 1000 minus x4, but x4 is what? T. Okay. So x1, x2, x3, x4. So if you want to fix, you can fix for t. But in the question itself, they gave what? The first question is what? Is the solution is unique? No, the solution is not unique. It has infinitely many solutions. So first part is over. If x4 equal to 200, determine the traffic flow. Okay. So I took x4 equal to what? T. So if x4 equal to 200, you'll get x1 equal to 600, sorry, 800, and x2 is equal to 800, and x3 is 1600 minus 200 minus 200. Actually, this is T, then X4 is T. So 1400 and X4 is 200. Okay, so that's our problem is over. So next, here again, I'll give some of the problems, a worked example as well as exercise problem for practice as well as for assignment. So this is the first problem in the assignment. So balance this equation. The solution is here. Okay, but don't see the solution, just will try. Okay, so I think you know how to solve this problem. I'll be explained to you. This is the first problem in the assignment. The solution is here. This is the second problem, assignment, balance equation, balance the chemical equation. Solution is here. You can check the solution. This is the third problem. This is the fourth problem. This is the fifth and the sixth. So to balance the equation, I gave 6 problem for practice and for assignment. I will tell the last the last date is you should submit coming Sunday. Okay, Sunday before 10 p.m. you need to submit in the GCR. Okay, next. This is actually system of linear application of linear system, that is a traffic flow. So these are some introductions here I gave. So please go through it. And this is the network analysis using linear system. Okay, so now I'll go directly to the problem. So this is the figure 1.91 shows a network with 4 nodes in which the flow rate and the direction of flow in certain branches are shown. Okay, find the flow rates and the direction of flow in remaining branches. So again, I'll repeat here what is given. So actually in this diagram, 4 nodes are there in which flow rate, this is the flow rate, okay, 15, 55, 30, 35, 60 are flow rate, and directions. Directions of flow in certain branches are known. For certain branches, it is not known. For this for here, I don't know. Okay, which direction? Here also I don't know. Here also I don't know. Here also I don't know. Okay, so here as illustrated in figure 1.92, we have assigned arbitrary directions to the flow rates x1, x2, x3. So originally here you have what? Just the diagram. I took what? This is x1, this is x2, this is x3. Okay, I think this is x4. But here, check it. 15. They gave it is a 15. So there is no need to take x4. So x1, x2, x3. Because these 3 are, we don't know. Okay, well, that's why I'll take x1, x2, x3. So the direction is arbitrary. So you can put either this way or in the opposite way. That is not a problem. Okay. So the direction is your choice. But I will tell you later now. Okay. We need not concerned if some of the directions are incorrect, since an incorrect direction will be signaled by a negative value for the flow rate when we solve the unknowns. So once we receive the negative value, then we will change the direction. Okay. Now, after drawing this diagram, you should write it follows from the conservation of flow at node A. So what is node A? This is node A. So x1 and x2 are leaving. So x1 plus x2 is equal to what? 30. Similarly, for node B is where? Here. So x2 plus x3 is equal to what? 35. Next, node C. This is node C. Okay, well, x3 plus 15 equal to what? 60. Node D, x1 plus x15, both of them are going into D. That is equal to what? 55. Okay. So now from the first equation, so these four conditions produce the linear system. What is the first equation? x1 plus x2 equal to what? 30. Second equation, x2 plus x3 is equal to 35. Third equation, x3 equal to what? 45 directly. x1 equal to what? 40. So if x1 is 40, x2 is 45. So clearly x2 is what? x2 is minus 10. x2 is minus 10. Earlier I told that negative, since an incorrect direction will be signaled by what? Value, negative value. So here x2 is what? Minus 10. So the fact x2 is negative tells us the direction signaled to that flow in figure 1.92 is incorrect. That is, the flow in that branch is into node A. Okay, well, so this should be this direction, into node A. Okay. Next problem, design of traffic patterns. So here, so please write the question, this question. Okay. The network in 1.9.3. Actually, I sent this PDF I think today morning I sent 5 PDFs. You can see your cell phone traffic flow problems. This problem is one of the problem. The network in figure 1.9.3 shows a proposed plan for the traffic flow around a new park that will house the Liberty Bell in Philadelphia, in Pennsylvania. The plan calls for a computerized traffic light, at the north exit on 5th Street. So this is the 5th Street. The plan calls for a computerized traffic light here. Traffic light at the north exit of the 5th Street. And the diagram indicates the average number of vehicles per hour that are expected to flow in and out of the streets that model the complex. So all streets are one way. The first subdivision A. How many vehicles per hour should the traffic light let through to ensure that the average number of vehicles per hour flowing into the complex is the same as the average number of vehicles flowing out. So that is the first part. Okay, first we will discuss the first part and then we'll go to the second one. Okay, and draw the diagram, this diagram. What they're asking in subdivision A, anybody? What is they are asking in subdivision A? So I'm expecting answer from one of you. What we need to find out from subdivision A. Number 12. Truth with Reddy is here. Okay. Actually, we need to find here. So actually, we need to find how many vehicles are through this traffic light. We need to find out. Okay, so let us take X be the number of vehicles uh, is going through what? Traffic light. Because the question is what? How many vehicles per hour should the traffic light let through? To ensure what? To ensure the average number of vehicles per hour flowing into the complex is same as what? Average number of vehicles flowing out. So under this condition, okay, we need to assume what is you need to assume. The average number of vehicles per hour flowing into the complex is same as what? The average number of vehicles flowing out. Okay, under this condition, now how many number of vehicles, okay, let through what? Going through traffic light. So let us take, I'll take this is X. Okay, so let X denotes the number of vehicles per hour that the traffic light must let through. Okay, then the total number of vehicles per hour that flow in and flow out the complex. What is flow in? Flow in. Flow in is what? 500 plus what? 200 plus 500 plus 200 plus 400 plus 600 equal to 100, sorry, 1000, 1500, 1700. This is what? Flowing in. Flowing in. Flowing out. Flowing out is what? 700 plus X. X is also out, okay, and 400. So now you have x plus 1100. So, but your this is out, okay, x plus 1100. So, and your assumption is what? Flowing in is same as what? Flowing out. So, if you equate these two, you will get x is what? X is 600. So, 600 is the answer. The answer is very simple, okay, but only thing you should understand the question and it should give the answer. So, here you can see if as indicated in 19, okay, that is a this is 1.9.3a, 1.9.3b is the next slide. Okay, so we let x denote the number of vehicles per hour. So this is x. Okay, so this is what? X. Denote the number of vehicles per hour that the traffic light must let through. So then the total number of vehicles per hour that flow in and flow out of the complex will be. So flowing in is, already I told that 1700. Flowing out is what? X plus 1100. So equating the flow in and the flow out shows the traffic light should let X is equal to what? 600 vehicles per hour pass through. So this is the first part. Over. Second part, assuming that the traffic light has been set to balance the total flow in and flow out of the complex, what can you say about the average number of vehicles per hour that will flow along the streets that border the complex? Okay, so we need to assume what? Assuming that the traffic light has been set to balance the total flow in and the flow out of the complex. We need to what can you say about the average number of vehicles per hour that will flow along the border of the complex? Okay, so that means you need to find the values of x1, x2, x3, x4. Okay, we'll try to do it. So this is, I'll take, already I told that this is what? X, but X is what now? We found out 600. So to avoid part B, to avoid traffic congestion, the flow in must equal to what? Flow out at each intersection. For this to be happen, the following conditions must be satisfied. At junction A, x1 plus x2 is what? 600 plus 400. Similarly, at junction B, x2 plus x3 is 400 plus x. But x we know that what? 600. Okay, at junction C, x3 plus x4 is equal to 500 plus 200. At junction D, x1 plus x4 equal to 700. So with x is equal to 600 as computed in part A, we will obtain the following linear system. So x1 plus x2 is 1000, x2 plus x3 is what? 1000, x3 plus x4 is 700, and then x1 plus x4 is what? 700. So from this, you should form the matrix. Okay, so you should form they gave directly the solutions. Okay, you need to do here, form the matrix, and then augmented matrix, and find the rank of A and find what? Rank of A comma B. But here they told that the system has what? Infinitely many solutions. Infinitely many solutions. So please check it. Okay. However, so x1 is the 700 minus t, x2, this is x2, this is x3, this is x4. Okay. So however, the parameter t is not completely arbitrary here. So usually we say that the parameter is arbitrary, but it is here, it is not completely arbitrary here. Why? The reason is since there are physical constraints to be considered. So what is the physical constraints? For example, the average flow rate must be non-negative. Okay, already I told that the flow rate should be non-negative. Since we have assumed the streets to be one way, we are assuming that the streets to be one way, okay, that is given the problem, and a negative flow rate would indicate a flow in the wrong direction. So this being the case, we see from equation 1 that t can be any real number that should satisfy t should be lies between 0 and 700. So in this case only the values of x1, x2, x3, x4 are non-negative. So which implies the average flow rates along the streets will fall in the range. Okay. So x1 is 700 minus t means t maximum 700. So if it is a 700, x1 is 0. Minimum 0. 0 means x1 is 700. So the values of x1 lies between what? 0 to 700. Similarly, the value of x2 lies between 300 to 1000. When t is 0, it is 300. When t is 700, it is 1000. Similarly, x3, x1 and x3 are same. So x3 is also what? Lies between 0 and 700. x4, so just a t is what? 0 to 700. So this is the final answer for part B. Okay. Now, assignment problem in traffic flow. Already I gave, how many problems I gave? 6 problems, 6, okay. So here this is the first problem, this is the second problem, third and fourth problems, okay. In traffic flow, there are 4 problems, 6 plus 4, 10. Okay. So the next topic is population growth. Okay. So matrices can be used to form models from population growth. The first step in this process is to group the population into age classes of equal duration. For example, if the maximum lifespan for a member is m years, then the n intervals below represent the age class. So maximum age is m years. Okay, so I divide the total number of years by n. The first age class should lie between 0 and m by n. Second age class lies between m by n to 2m by n. Similarly, it goes on. The age distribution vector x, this is age distribution vector x, represents the number of population members in each age class. So x1 denotes the number of the total number of people in the first age class. X2 is the total number of peoples in the second age class. Similarly, xn is the total number of peoples in the nth age class. So capital X, this x is age distribution vector. Okay. Next, over a period of m by n years, the probability that a member of the ith age class will survive to become a member of I plus 1th age class is PA. Okay, so where PA lies between, because it is a probability, that's why it lies between 0 and 1. What do you mean by P1? Okay, well, P1 means the probability that a member in the first age class will survive to become a member of the second age class. So that is called P1. Similarly, P2 means a member of the second age class will survive and become a member of third age class. That is P2. So Pn minus 1 means a member of n minus 1th age class will survive to become a member of nth age class. So the I varies from 0 to n minus 1. So So maximum number of years is what? N. Okay. So he will not survive after n years. So next, the average number of offspring produced by a member of the ith age class is Bi, where Bi is greater than or equal to 0. I from 1 to n. I ranges from 1 to n. So these numbers can be written in the matrix form as shown below. L equal to the first row is offspring produced by each of the age class. So okay, B1 means what? The average number of offspring produced by the member of the first age class is B1. So B1, B2, first row you should write the offspring. The second row, the first element, you should write P1 because you have what here? P1 to what? Pn minus 1. So this is the n by n matrix. P1, P2, and the next P3, and then finally you should write what? Pn minus 1. So this is age transition matrix. So multiplying this age transition matrix by the age distribution vector. What is the age distribution vector? Capital X. Okay, multiplying this age transition matrix by the age distribution vector for a specific time period produces the average distribution vector for the next time period. So that is L into Xj is equal to Xj plus 1. So age transition matrix L is also called Leslie matrix after the mathematician Patrick H. Leslie. Okay, so now I'll directly go to the problem. Now I'm going to solve this problem without the matrix, without the concept of using matrices. Later I will tell how to solve the same problem by using matrix. Okay, so please write the problem. A population growth model. A population of rabbits has the following as the characteristics below. First one, A. Half of the rabbits survive their first year. Half of the rabbits survive their first year. Of those, half survive their second year. The maximum lifespan is 3 years. Next, subdivision B. During the first year, what about Nishant, whether you joined the meeting or not? Just now I received a message from Nishant. Sir, I had been removed from the meeting, but I am not doing anything. Maybe automatically you may remove. Okay. So, okay. Solution B, during the first year, the rabbits produce no offspring. Next, the average number of offspring is 6 during the second year and 8 during the third year. The population now consists of 24 rabbits in the first age class, 24 in the second age class, 20 in the third age class. how many rabbits will there be in each age class in first year? Similarly, one more question you can add. Okay, one more question. How many rabbits will in each class in 2 years? That is one more question. Okay. So first here the population now consists of 24 rabbits in the first age class. So 24. So I told that x1 is what? The age distribution vector. Okay, x1 is what? Age distribution vector. The current age distribution vector is, you can see, so x1 equal to 24 because it is given in the question. The population now consists of 24 rabbits in the first age class. This is the first age class. The maximum lifespan is what? 3 years. Okay, 3 years, 0 to 1, 1 to 2, 2 to 3. Okay. Second age class, 24 in the second age class, 20 in the third age class. So this is the age distribution vector. This is the current age distribution vector. Okay. Now, I don't know this matrix. Okay. I will tell you later how to form this matrix. But so those who does not know the concept of matrix, how to solve this problem. Okay. So during the first year, the rabbit produces no offspring. Okay, the number of offspring is 6 during the second year. Okay, so second year, how many rabbits are there? 24. So 24, each one produces what? How many rabbits? How many rabbits? I'll pay some part. The average number of offspring is what? 6 during the second year. So 24 into 6 plus, and 8 during the third year. So in the third age group, how many rabbits are there? 20 rabbits. So each rabbits produce what? 8. So 24 into 6 is what? 144 plus this is 160. So we'll get what? 304. So this is 304 in the next year, after 1 year. Okay, 1 year. The value of x1 is what? The value of x1 is what? The first component is 304. I think we got it here. 304. Okay. Next, after 1 year, half of the rabbits survive their first year. So that means first year, how many? Initially you have how many rabbits? 24. So half of them is survive in the first year. Means what is half of 24? 12. Okay, after 1 year, you have only 12 in the second age group, because these 24, after 1 year, it will become the third age class. Okay, that is the age between what? 2 and 3. Okay, so next, again, half of the rabbits survive their first year. So out of 24, next this 24 is from what? 1 to 2. Half of them is what? 12. This 12. Half of 24 is this 24 is this 12. Half of this 24 is 12. Okay. Next, this is a first year end. You have 304 members in the first age, 12 members in the second age group, 12 members in the third age group. Up to now, I am not using matrices. Okay. Next, first, how many rabbits will be there in each age class in first year is over. Now I added one more question. How many rabbits will be there in each age class in second year? Okay, well, second year again I am going to use. Okay, here you can see of those half survive. Here you can see of those. Again, I'll repeat the question. First part: half of the rabbits survive their first year. Okay, well, okay, that we discussed already just now. Of those, half survive their second year. Okay, well, so now after 2 years, half of 304 is what? 152. Okay, 152, half of 304. Because no offspring in the first year. There is no offspring in the first year. So that's why just half. Okay. Next, in the age group of 1 to 2. In the age group of 1 to 2. Sorry, I think I done it wrong. Here, 152. In the second age. Okay, well. Yes, because 304. Okay, and the first age class, how many of them will come? First age class. First one is okay. Okay. Here 304, how I told? 24 into 6. Okay, good. So similarly, I think here we have what? 12. Okay, well, there is no offspring in the first year. So 12 into, okay, in the second age, each of them produce what? 24 rabbits, sorry, here. Okay, the average number of offspring, the average number of offspring is 6 during what? Second year, and 8 during the third year. So 12 into 6, this 12 into 6, plus this 12 into what? 8. 8 during the third year. Okay. The first case I put what? This 24 into 6, this 20 into what? 8. I got 304. Okay. Now this is 72 plus 96. Sorry, 96. So we'll get 168. So 168 is here, and 152 comes because I told that of those half survive that second year. Okay, well, so out of 304, half of them survive the next year, 152. So next, out of this 12, okay, well, out of this 12, half of them survive in the next year, that is 6. So 150, 168, 152, 6. You can check it. So you can check it, 168, 152, 6. This is I got from matrices, using the idea of matrices. But here I don't use any matrix idea, just this is a problem. Okay, well, I solve the problem using without matrices. Okay, is it clear, or if you have any doubts, you can ask to me. I will explain. First without matrices, and then we will go how to use matrix, and then to get the same answer. Okay, otherwise just go through it. If you have any doubts, you can ask tomorrow in the classroom. Okay. So now I'm going to explain how to solve the same problem by using matrices. Okay. So now x1, I already told that X1 is what? The age distribution vector. That is the first year what? First age class is what? 24. The second age class 24. Third law 28. So L, the L is what? Age transition matrix. The first row is what? Offspring. So during the first year, the rabbit produces no offspring, so 0. The average number of offspring is 6 during the second year, 6, and 8 during the third year. Okay. Next, here P1, P2. So P1 is half of the rabbits survive their first year. Always P1 and P2 are lies between, it's a probability, it lies between what? 0 and 1. Half of the rabbits survive their first year. So originally, whatever it is, you should put 0.5. Of those, half survive the second year. So here also you can put what? 0.5. Don't put 0.25. So if you put 0.25, it is wrong. So you should take this. This is a whole and then find out. Yes, Mahashri. Okay. So I think I explained well. Explained somewhere else. I forgot it. Okay. 160, yes. Oh, yes, here I explained. Okay, P1 and P2. Okay. So what I told P1 is half of the rabbits survive their first year. Okay. So that's why 1/2. Of those, half survive their second year. So don't write here 1/4. Okay. So consider this is a whole. Half of this, that is again 0.5. So look at, originally we have what? In the first year, 24. Okay. In the second year, in the second year, you can check it. Here, you can check it. Half of 24 is what? 12. Again, okay, answer 24, half is what? 12. Half is what? 6. So that means 24 into 1/4 is 6. That is correct, but it is not 1/4 of this 12. Okay, so this 1/4 is a whole. This is the whole. Okay, now if you consider this is 12. Okay, if you now you should consider this is the whole. You should find 1/2 of this 12. You will get 6. Okay. Okay. Now I'll come to, okay, once you got the matrix L, after first year, the age distribution vector, how to get the age distribution vector after 1 year? Capital X2 into LX1. What is L? This is the age transition matrix L into X1. X1 is this X1. If you multiply these two matrix, 3, 0, 4, 12, 12. So already I told to you how to get without using matrices. Okay. So this is X2 is the question they're asking what? How many rabbits will be there in each class after 1 year? The problem is completely over. Suppose if they ask the question, how many rabbits will be in each class in 2 years, what you need to do? So you need to find out X3 is equal to L into X2. X3 equal to L into X2. So you know what is L. So sorry, you know what is L. But the L is what? Age transition matrix. And X2. So this is your X2. This is your X2. So if you multiply L into this X2, you'll get X3. X3 is this matrix. Okay. Already I told you how to get X3. This is X3 without using matrices. Okay. So now 5 minutes break. Have a tea, coffee, ice cream. Okay. Come back. Okay. But during this 5 to 7 minutes break, try to solve any one of the problem. Okay. At least solve the first problem. Okay. At least solve this problem. Population growth model. This problem. There are 3 problems are there. Okay. Try to solve the first problem. So I also have some tea and then come back within 5 minutes. Okay. Can we start the class again now? So anybody got the answer for the first problem? A population has a total of, okay, for this problem, everybody got the answer? If you got the answer, you can tell. How many members will be there in each class after first year and in second year? Anyone? Okay. So now what is x1? At least you can tell. What is x1? So the x1 is what? The current age distribution vector. What is the current age distribution vector? Trisha? Shivani Hari?
160, 160.
Yeah, 160, 160, 160. Okay. It is given here. The population now consists of 160 members in each of the 3 age classes. Okay. What is L? What is the first row? The offspring. Yeah. The average number of offspring in each member, okay, of the population is 2 in the first year. Okay, 4 in the second year, 2 in the third year. Okay, 2, 4, 2. And then P1, P2. What is P1? A total of 75% of the population survive their first year. So that is 75 means, so 3 by 4, 0, 0. So out of 75, 25 survives the second year. The maximum lifespan is 3, 0. What is next?
1 by 4.
Yes, 1 by 4 is correct. 0. So next we should find x2. x2 is equal to L into x1. Okay, this is L, this is x1. So this x2 is what? The answer for how many members will be there in each class in first year. So next, in 2 years means you should find x3. x3 equal to what? L into x2. So that's all. You need to find x2 and x3. So after this is the answer. The x2 is the answer for the first question. How many members will be there in each class in first year? x3 is the answer for the second question. How many members will be there in each class in 2 years? Okay. Similarly, try this problem and this problem. Okay. And this is the first problem. This is the second problem. This is the third problem. Also assignment problem. And already I gave 6 problems in balance equation, 4 in traffic, and 3 in population growth. So 13. The next problem, finding a stable age distribution vector. So before to go into the examples, I want to discuss with you the previous problem. Just the previous problem is just now we discussed. That is example 1. So actually here, what is x1? This is x1. x1 is what? 24, 24, 20. x2 is what? 304, 12, 12. And x3 is 168, 152, 6. Okay. So notice from the age distribution vector x1, x1, x2, and x3 that the percent of rabbits in each of the 3 age classes changes each year. Okay, to obtain a stable growth pattern, one in which the percent in each age class remains the same each year. So the n+1th age distribution vector, that is xn plus 1. Okay, n+1th age distribution vector means what? xn plus 1 must be a scalar multiple of nth distribution vector. We know that xn plus 1 is equal to what? L into xn. Okay, but that xn plus 1 should be what? Some scalar multiple of nth age distribution vector, that is lambda into x power n. Okay, now you know the matrix eigenvalues and eigenvectors concept. A into, instead of L, assume A into x is equal to what? Lambda into x. Okay, so now I am going to use the idea of eigenvalues, eigenvector to find the stable age distribution vector. Okay. Okay, find a stable age distribution vector for the population in example 1. The problem is same, but only the difference is what? We need to find a stable age distribution vector. Okay, so to solve this problem, first we should find the eigenvalue and eigenvectors x such that Lx is equal to lambda x. Okay, for this matrix L, okay, for this matrix L, we should find the characteristic equation, and then we should find what? Eigenvalues. So please check the eigenvalues are -1, -1, 2. Okay, this is the characteristic equation for L. Okay, so choosing the positive eigenvalue, that is lambda equal to 2, the corresponding eigenvectors are of the form. So the corresponding eigenvector is 16t, 4t, t. So if you take t common, you have what? 16, 4, 1. So you need to check this also. So I think you know how to find the eigenvalues, eigenvector. That's why I'll skip that part. So for example, if t equal to 2, there is no need to take t equal to 2. You can t equal to 1. Okay, you can take t is also 1. Okay, in the book they are taking t equal to 2. Then the initial age vector is x1 equal to what? 32, 8, 2. So the first age group we have 32, the second age group we have 8, the third age group we have 2. And the age distribution vector for the next year, that is x2 is equal to L into x1. You will get what? 64, 16, 4. So that means, notice that the ratio of the 3 age classes. Okay, what is x1? x1 is 32, 8, 2. x2 is what? 64, 16, 4. So that means they are in the ratio 16 is to 4 is to 1. This is also what? 16 is to 4 is to 1. So we have the percent of the population in each age class remains the same. So this is actually what? A stable age distribution vector. So to find the stable age distribution vector, so we are using what? The concepts of eigenvalue and eigenvector. Okay, so I think population growth model is also over. So next topic is singular value decomposition problem. Okay. Singular value decomposition. Singular value decomposition. In bracket SVD. So I'll give the procedure. Please write the procedure. So maximum I'll take 15 to 20 minutes to finish one problem. So let the given matrix be capital A. First step, find A transpose into A. Find A transpose into A. Second step, find the eigenvalues. Find the eigenvalues of lambda I of A transpose into A. A transpose into A. Let sigma I equal to root of lambda I. Okay, and then third step, find the eigenvectors find eigenvectors capital Xi of A transpose into A. So that is for this eigenvalue lambda I, you need to find the eigenvector. And then fourth step, find normalized eigenvector of Xi. Find normalized eigenvector of capital Xi, say Ui, and form the matrix capital U is equal to U1 row matrix, U1, U2, and so on. So next step number 5. Find Ui dash is equal to 1 by sigma I. 1 by sigma I. Sigma I is, I told that this sigma I into capital A into Ui. Okay, Ui, I think here you got the normalized eigenvector. And form the matrix U dash, capital U dash. This is U, this is U dash. Equal to, again, this is a row matrix. This is U1 dash, U2 dash, and so on. U1 dash, U2 dash, and so on. Okay, next step number 6. Step number 6. The singular value decomposition equal to singular value decomposition is equal to U dash. So U dash is this U dash and this matrix. Okay, I will tell what is this here. This is summation, but this is a matrix, and then U. This is just notation. So I'm writing the matrix A, the given matrix A is equal to 3 matrices, where U dash is equal to, already I told that what is U dash. What is U dash? U1 dash, U2 dash, and so on. And this summation is the diagonal matrix whose diagonal entries are sigma 1, sigma 2, and so on. I think you know what is U. U is here, it is U1, U2, and so on. Now I'll directly go to the problem. First problem. Obtain the singular value decomposition of obtain the singular value decomposition of decomposition of the matrix A is equal to 2, 1, 1, 1, 1 minus 1. So I am expecting you should do some work here, and suppose if I ask some question, you should respond. Okay. So first step, you should find what? A transpose into A. A transpose is what? 2, 1, 1, 1, 1 minus 1. This is A transpose into A. A is 2, 1, 1, 1, 1 minus 1. So if you multiply these two matrices, you will get first row column. So 4 plus 5 plus 1. So 6. Take the first row and the first column. 2, 1, minus 1. So 2. 2 plus 1, 3. 3 minus 1, again 2. 1, 1, 1. So 3. This is the matrix. What? This is we are calculating what? A transpose into A. So this is what? A transpose into A. So we need to find the characteristic equation of A transpose into A. Next step. Characteristic equation of A transpose into A is, so lambda square minus trace. Trace is what? 9 minus 9 lambda. What is the determinant? 18 minus 4, so 14 equal to 0. So the roots are 7 minus 2 into 7 minus 4 equal to 0. This implies, so lambda equal to what? 2 comma 7. Okay, so take lambda 1, lambda 2. So lambda 1 equal to 2, lambda 2 equal to 7. So after finding the values of lambda 1, lambda 2, next you should find what? Sigma 1 and sigma 2. Sigma 1 is what? Root of lambda 1, that is root 2. You can keep as it is root 2, or you can write in decimal 1.41. Next, sigma 2 equal to root of lambda 2. It is root 7. Root 7 is 2.65. So after finding sigma 1, sigma 2, you should find the eigenvectors next. Okay, eigenvectors corresponding to lambda equal to 2 and lambda equal to what? 7. Eigenvector corresponding to lambda 1 equal to 2 is the matrix A minus lambda I into x1 equal to 0. So what is the matrix A minus lambda I? So actually not A, actually A transpose into A. Okay, wow. Okay, A transpose into A. What is A transpose into A? 6 2 2 3. 6 2 2 3 into x1 x2 x3, sorry, x1 x2 is equal to 0 0. If you substitute lambda 1 equal to 2, you'll get 4 2 2 1. You'll get x1 x2 equal to 0 0. Okay, so now 4x1 plus 2x2 equal to 0. Next to 2x1 plus x2 equal to 0. Okay, so 4x1 plus 2x2 equal to 0, 2x1 plus x2 equal to 0. Okay, now so from this, I think both the equations are what? Same equations. So from the second equation, 2x1 equal to what? Minus x2. So I will take x2 equal to what? Some k. So what is capital, what is small x1? Small x1 equal to k by 2. x2 equal to minus k. So k, let us take k equal to what? Can 2 or minus 2. So I will take k is 2. But take k is 2, what is x1? The first eigenvector is 1 and minus 2. 1 and minus 2. This is x1. So next, okay, you can directly find next normalized eigenvector. Normalized eigenvector for x1 is 1 by root 3. Okay, 1 by root 3 you can write, okay, or otherwise you can write in fraction. Okay, 1 by root 3 is 0. You can check it, 0.4472. Similarly, not 1 by root 5, 1 by root 3, actually 1 by root 5. Okay, 1 by root 5 minus 2 by what? Root 5 minus 0.8944. So this is equal to u1. Next eigenvector. Yes. Yes, please tell. Okay, so next eigenvector. Eigenvector corresponding to lambda 2 equal to 7 is, so again you need to find out eigenvector. I will write directly x2, the value is 2 and 1. So please check it. The normalized eigenvector. Normalized eigenvector for x2 is 2 by, again, root 5. 2 by root 5 is 0.8944. 0.44, and 1 by root 5 is 0.4472. So I'll take this as u2. Okay, now capital U is equal to the row matrix u1, u2. What is u1? What is u2? So u1 is 0.4472 and minus 0.8944, and u2 0.8944, 0.4472. Okay. Next, after finding u, if I'll go to for u dash. U dash is, we know that it is u1 dash and the u2 dash. So here u1 dash. Okay, what is ui dash? In general, again, ui dash is what? 1 by sigma I into a into ui. So if I substitute I equal to 1, we have u1 dash equal to 1 by sigma 1 a into u1. So which is equal to 1 by sigma 1. What is sigma 1? Sigma 1 is 1.41. Sigma 2 is 2.65. 1.41. A, the matrix A is a given matrix. 2, 1, 2, 1, 1, 1, 1, minus 1. So this is the given matrix U1. So what is U1? The normalized eigenvector. So this is U1. It is 0.4472 minus 0.8944. Yeah, so if you multiply these two matrices and divide by 1.41, so finally you will get 0 minus 0.3172 and then 0.9515. Okay, so this is U1 dash. U1 dash. So next you should find what? U2 dash. I equal to 2. So U2 dash is equal to 1 by sigma 2 into A into U2. So which is equal to 1 by sigma 2. I already told that 2.65. A is a given matrix. The given matrix is what? 2, 1, 1, 1, 1, minus 1. This is A. And the U2. U2 is this matrix 0.8944, 0.4472. So this is U2. Okay, after multiplying these two matrices and divide by 2.65, we will get U2 dash is equal to, so please verify using calculator, 0.8438, 0.5063, 0.1688. Okay, so now U dash is equal to the row matrix U1 dash and U2 dash, which is equal to, what is U1 dash? So this is U1 dash. Okay, U1 dash is U1 dash is 0 minus 0.3172 and then 0.9515 and then u2 dash is 0.8438, 0.5063, 0.1688. So this is u dash. So I think now we got everything. So A is equal to, we are in the final stage. So A is equal to the singular value decomposition is singular value decomposition. Is the given matrix A is equal to u dash the summation into u. So what is u dash? Okay, just now we found u dash 0.8348, sorry 38, so 8438, 8438 and the minus 0.3172 and here 5063 and then 0.9515, 0.1688 and then sigma. Sigma is, I already told that it's a diagonal matrix whose entries are what? Sigma 1 and sigma 2, it is 1.4100, 2.65 and then u, the matrix u is 0.4472 and 0.8944. Okay, I don't have enough space here. I'll write here. Zero point 4472, 0.8944 and then minus 0.8944 and then 0.4472. So this is the singular value decomposition. Okay, so I will give some practice problem okay, in singular value decomposition and then I'll close this session. We are discussing what singular value decomposition. Okay. Now try to solve this problem. Okay. This is the first problem, and then second problem is a 3 by 3 matrix. I'll give you 3 by 3 matrix. In singular value decomposition, okay, so try to solve these two problems. Okay. Okay, so that's enough. So nearly I finished 4 topics, but only thing is I covered everything in the online. Okay, so that's why if you have any doubts in the today class, that is balancing chemical equations, traffic flow, and then what? The population growth model and singular value decomposition, you can ask tomorrow's class. So I will ready to explain. And this is one of the advantage. Actually, I want to explain this concept in the projector because it contains so many concepts of theory. If I give the theory in the class, it will take time. So fortunately, I have an online class here. So I'm using that online class to explain these concepts. Otherwise, I should take everything in the using projector. I will explain. Okay, because the next topic is also electric circuit. So it contains lot of diagrams. Okay, so if I do everything in the board, it take time. Okay, so now the remaining 2 topics are electric circuit and the principal access theorem. So once I finish those 2 topics, matrices is over, and then we'll go to either 3rd unit or 4th unit. I am thinking about to start the 4th unit because the 4th unit is a little bit difficult than the 3rd unit. So if I finish the difficult one a little bit earlier, then easier one maybe I will finish a little bit later. Okay, I will let you know later. Okay, first I will finish the 2nd unit. Okay, so thank you everyone. We'll meet tomorrow.
Sir, attendance.
Attendance, Indrajit, actually automatically I will receive the
Yes, sir.
attendance
Solonga, sir.
during my to my mail. Okay,
Okay,
mail
sir.
வந்துரும். ஓகேவா?
சரியா சார்?
நீங்க எத்தனை மணில இருந்து எத்தனை மணி வரைக்கும் அட்டெண்ட் பண்ணீங்க அப்படின்னு டூரிங் அந்த டைமோட வந்துரும் எனக்கு வந்துரும்.
ஓகே சார்.
ஸோ ஓகே, அதனால நீங்க அதை பத்தி பிரச்சனை இல்லை. ஓகேவா?
சரியா சார்?
ஓகே.
ஓகே சார்.
But I corrected your paper yesterday.
Yes, sir.
Actually, I want to give the paper today. So again, I don't know because of this rain. Okay, I think tomorrow we will meet. But I'm not satisfied with your performance. I will openly tell. Okay, I'm expecting you should do more in the 2nd CA.
Okay,
So
sir.
okay.
Okay,
You
sir.
can see your marks in the 1st CA marks. And actually, I'm really disappointed with your performance. Okay, thank you.
Okay, sir.